So the question that we're going to look at today is subarray sum equals k. In this question, basically, you'll be given a value of k, which could be anything, and a array. You have to find out the number of subarrays in the given array, the elements of which are going to sum up to, if you add them all up together, they're going to sum up to the value of the k that you're given. So if you look at this example, you're looking for k is equal to 2. So if you add up 1 and 1, that's one subarray, which is going to give you the value 2, and this 1 and 1, and it's going to give you the value 2. So basically, two subarrays that are going to give you the value 2 if you add up all the elements in them. So now that we know what we want to do, let's try to understand this question a little better. Based on a concept called prefix sum, which goes something like this. If you have an array with a few elements in it, and if I tell you that the sum from this index to this index is 3, and the sum from this index to this index is 5, then what is going to be the sum from, what would be the sum from this index to this index? It obviously is going to be 2, right? So basically, if you know the difference, or even if you know the whole sum from one point to another, and from this point to this point we have the sum, and we have the sum from this point to this point, then we can find out what the sum from this point to this point would be. So let's look at an example to clear it out even further. How is it relevant to the question that we are looking at? So if you are given an array which has numbers like this, 4, or let's actually take 5. So let's take 5, 4, 5, 2, 0. Let's take -2, 9, and -7. And let's say now the k is equal to 7. Okay. And now if at every point, if I kept maintaining the sum from here to here, this point is -2. The sum from here to here is 3. The sum from this point to this point is 7, which is what we were looking for. Then the sum from this point to this point is 12. From here to here, it's 14. So now if you look at this, what are we getting? So we found out that the sum from here to here is 7. Basically, for these indexes, the sum is 7. This is what we found out. And the second thing that we found out is that the sum from this point to this point is 14. So what does that mean? That basically means that if you add up elements from this index to this index, it would be 7, right? Because 14 minus 7. So you have 7, which is what we were looking for. If you continue, the sum from this point, even if you continue, the sum from this point to this point would again be 14. Which means that this window can actually be extended. Here, it is still 14. And this is still 7. This is also 7. So at this point also, the value would be 7, right? The sum is remaining 7 because it's the element that we added is actually 0. So let's try to look at how we can code this out, how we can use whatever we've learned so far. Let's go back to the example that we had, which was -2, 5, 4, 5, 2, 0, -2, 9, and -7, and k is equal to 7. Let's create a map now. So map for storing the sum that we've seen so far. Okay, so when you start from this index, what is the sum that you're getting? It is -2, right? Now the value that we want to look for is going to be the difference between the sum that we've kept so far, which let's call it running sum. So the sum that we've got so far subtracted by the value of k. And if you found that number before, that means that the subarray that you're looking at, it's going to give you the value k. we'll look at the example and we'll clear this out even further. But so what we've learned so far is that we want to have the running sum, which is actually at this point -2. So we want to take -2, which is the running sum. We want to subtract 7 from it, which will give us -9. Have we seen our map right now is empty? So have we seen -9 before? No. So, and let's keep the count also. Count in the beginning is equal to 0. So we haven't found -9 before this. We haven't encountered this running sum till this point, so we cannot increment the count. But we have to add the running sum to the map. So because this is the sum that we've found so far. And how many times have we found it? We found it just once. We go to the next element. We get the sum as 3. 3 minus 7 is -4. Have we found it? No. So we don't do anything, but we add 3 and the count. Let's clear this out. Now, the sum that we found so far is, by this point, it would be 7. 7 minus 7 is equal to 0. We haven't found it yet, but we can just assume that it was 0 from the beginning, right? The running sum was was 0 from the beginning. So if we assume that, then you want to add 0 to your map to begin with. So 0 is present because that is the sum that we found before we even started. So by this point now, your sum is becoming 7. When you subtract 7 from the k that you're looking for, the value becomes 0, and 0 is present in the map. And the number of times we've encountered 0 so far is just 1. So the count is going to become 1 because you're going to add the value. Whatever you get from here, you're going to add that value. So count becomes 1. Now, if you look at, you move on, and you have to add 7 to the map, right? Because that is the sum that we found so far. Now we go on. We add 12. 12 minus 7 is 5. 5 is not in the map, so we don't do anything to the count, but we add 12 to the map. We move on. The sum becomes 14. 14 is not in the 14 minus 7 is in the map, right? Because 7 is present and it came once. So from this point to this point, our sum was 7. This is where the example is coming to help, right? From this point to this point, the sum is 7. And from this point to this point, it is 14. That means this is 7, which is what we were looking for. So we have this value right now. The running sum is 14 at this moment. And we are subtracting 7 from it. And we are checking that we found 7. We've seen 7 before. How many times? Just once. So the number of subarrays, the subarrays that would give up the sum of 7 is just 1. So you add the value 1 to it. Move on, add 14 because you got it once. Now you move on again. The running sum is remaining 14 and the difference is remaining 7. 7 is present in the map. So you increment the count by 1. And 14, how many times you've seen 14? You've seen it twice. So now 14 is going to be updated to 2. You saw it twice, right? By this point. Now you go on, sum is becoming 12. 12 minus 5 is not, 12 minus 7 is not present, but 12 is present. So increment its count by 2. Move on, add 9. 14 plus 9. Oh yeah, 12. Sum became 12 at this point, right? It became 12. So 12 plus 9 is 21. And if you subtract 7 from it, you would get 14. And you've gotten 14 twice, right? We've got 14 twice before this. So now you're going to add 2 to the count. And so it is going to become 5. If you look what it means in this here, let's look at it. What does that mean? The number of subarrays that we're looking for, right? So we found out that the sum from this point to this point is 21. And let's update the value over here. 21, we got it once. We found out that the value from here to here is 21. And if you subtract 7 from it, that gives you 14. And we saw that 14 has come twice. Where has 14 come twice? At what point? So we saw that the sum from this point to this point was 14. And the sum from this point to this point was also 14. So that means the first subarray, the 2 that we're getting over here, where is that coming from? The subarray, the first subarray that we're getting, that is giving us the value 7, is from this point to this point. That is the first subarray, right? If you add them up, it is giving you 7. That is the first subarray. And the second subarray is from this point to this point. That is the second subarray. That is the 2 that this indicates. That is the 2 that we added over here. Okay, now let's move on, go to next. The running sum is 21 so far. We added minus 7 to it, 14. 14 is already present in the map. So when you subtract 7 from it, you get 7, which came just once. So you increment the count by just 1 and you update the value over here to 3. And now you're done. You traverse the whole array. So the count in the end would be 6. This is the number of subarrays that you can form, the values of the elements of which would be 7. The sum of the elements from those subarrays would be 7. So now, what have we learned so far? At every point, we try to keep the running sum. We subtract the value of k from the running sum. We see if that value have we encountered it before? And if we have encountered it before, how many times? We use this number of times and we add the number of times to the count that we have. That is how we get the final count. So now let's start coding. We're going to need a hash map. So let's create a hash map. We're going to store the number of times we have seen the running sum against the number of times we've seen the running sum, right? So let's just call it map. It's equal to new hash map. Now, if you remember in the example, we had to put 0 beforehand because we saw it one number of times before we even began. The running sum was 0. So we want to put that in the map before we start going through the elements in the array. Now, the 2 things that we need is the count that we're going to return. Let's set it to 0 in the beginning. And we're going to need the running sum itself. Let's set it to 0 as well. Now let's start iterating through the numbers. Now your running sum will be equal to the number itself, right? And now if your map actually contains, if the map contains the running sum minus k, we are looking at the difference, right? So if it contains the difference, then we want to increment our count by whatever was the number of times that we'd seen that difference, we'd seen that running sum. So it is going to be map.get, and so you get the value from here. Right? And even if you found the value, you did not find the value, you have to update the map with the current running sum. So you want to put the current running sum, which is just the running sum, not the difference. And if you have the value, great. Otherwise you want to add, otherwise you want to say running sum comma 0 plus 1 and just return the count. So if you run it, let's try to use the example test cases. Let's try to run the test case that we came up with. We went through during our discussion, which was, it was -2, 5 comma 4 comma 5 comma 2 comma 0 comma minus 2 9 minus 7. The answer for this should be 6, right? Let's try to submit it and be good. I hope it helped. Have a good day.